Hello students, welcome to Lab 4. In the last few labs, we've really gone through the general workflow of data analytics. While we have focused on programming, obviously we've been using R this whole time. Really a lot of our main focus was on how do you apply these tools to do analytics. Really that's kind of been my approach for this class in general. It's not helpful for you to take this class and become a CS major. Either you've taken CS courses and you'll learn these concepts much better in those classes anyway, or you haven't and you're just interested in doing analytics. So in our first three labs, we went over the general analytics workflow in lab 1. We went over basic data manipulations and using the tidyverse in lab 2 and lecture 2. And in the most recent lab, lab 3, we did visualizations. And between those three things, that really covers about 90% of the work that you're going to be doing. In this lab, which should be a little bit shorter, we're going to step back a little bit and we're going to focus a little bit more on the CS side of things, but only insofar as it's concerned with tools that you may actually use on a day-to-day basis when you're programming in R. So as in the lecture, we're going to briefly go over different data types, what they're used for and how to manipulate them. We're also going to go over a new logical operator called in, excuse me, and we're going to talk about joins, specifically left joins. Now, there are other joins out there, and if you take your SQL class, you will learn all about them. But in general, for data analytics, if you know your left join, you're pretty much good to go. So why don't we get started, and let's look at our code here. Let me make that a little bit bigger. As always, we're going to start with the tidyverse. We're going to load that. Whoops. We're going to load our tidyverse library. It's already downloaded, already installed, as it always is. And we're going to load two data sets from our lecture, an education data set and an electricity data set. And just for your edification, both of these data sets are from the World Bank website. So if you're interested, you can go download this data from the World Bank yourself. We've also done a little bit of cleaning on these data sets. So if you choose to go download it from the World Bank, it won't be exactly in the format that this is, but it'll be pretty close. I haven't done that much cleaning on it, just enough to make this lab a little bit easier. So let's start in the beginning. What is a set, or rather in R, they're called vectors? Well, we've already been exposed to them a little bit. Recall when we did our scale argument in the last lab, and we wanted to say, hey, I want to tell ggplot to use these specific colors rather than the default colors that it uses. You'll remember that we kind of wrapped that argument, that set of colors, in a function that looks like this. It starts with the letter C and then just normal parentheses. C is really the function that creates sets of things, or vectors, and we can put all sorts of things in a vector. First off, we can put numbers in a vector, and you'll see that when I print that out, it'll just print them out one after another. There are, of course, unique elements in this set. It doesn't just squish them all together. It understands that each of those are different items, but it treats this object as its own thing. And, excuse me, just like any other object, we can assign it to an object. You'll notice that this vector kind of shows up in a different spot in our environment. While we have data, and these are data frames, and we'll get to that in a minute, our vectors show up here under values, right? A vector is a one-dimensional data type. You have basically just a set of rows. Whoops. You have basically just a set of rows. You don't have rows and columns. You just have one dimension of data, and so it shows up in the values section. This is what a set is, and in fact, we can do all sorts of things with sets. For example, we can multiply every element in the set by some number just by calling that object and doing times 2. We can do really any other type of logical comparison. For example, we can say, does it equal 2? And it'll say no, because we have 1, 10, and 20. And here you go. If we do, does data double equal 20, we'll get false, false, true, because 1 does not equal 20, 10 does not equal 20, but 20 does equal 20, right? So sets are very helpful when we kind of want to put a collection of things together, right? Like I said, we've already used this in our ggplot example, but you'll use it anytime you need to consider multiple things together. When we want to access different elements of our set, one way to do that is with a single square bracket And since a set has only one dimension, all we need to do is inside of this square bracket, we need to tell it which element am I interested in. Right? So if I put data, which is the name of this set object, I open a square bracket and I say 1, what I'm telling R is return whatever the first element in data is. And if we run that, we get 1. And if we do 2, we get 10. And of course, if we do 3, we get 20, right? So these are sets and how to access elements inside of them. Anytime you find yourself needing to pass more than one thing to an argument, you're almost always going to have to put it in its own set. I'm sorry, I almost sneezed. It's dusty in here for some reason. Okie doke. So we have covered sets or vectors. Now let's cover data frames. We already kind of have a data frame. So why don't we take a look at that? Data frames, education. At this point, we're quite used to data frames. We've been using them for 3, probably 4 lectures now. And so you're generally comfortable with the idea that in a data frame you have rows and columns. But it's worth kind of looking at this data frame a little bit more deeply and thinking about what's actually happening here. In a sense, a data frame is really just a collection of vectors, and each vector is basically a column, right? So note that, actually let's go back to sets for a reason, for a second. You can have sets of basically anything. 3, right? So you can have, and if we run this, we'll get that, right? So you can put a lot of things. In fact, you can even put mixed set. You can put mixed data types in here. But what's important to notice is that it's going to treat all of these items, elements in the set as the same type. Notice that even though 1 is a number, it's kind of treating it as a character. You see CHR right here. It's treating it as a character because everything in a set or a vector is treated as the same type. So let's go back to our data frame and think about the implications of that. Remember what I said? A data frame can be thought of as a collection of vectors, with each column being a different set or a vector. You'll notice that at the top of this data set, whenever we print it out, this data frame, it tells us what type that column is. So of course this is just kind of plain text, so it's treated as a character variable. Likewise, these are letters, and not really words, but just letters, so it's also treated as a character variable. This is an integer, it's a number, so it's treated as a double variable. For now, you can just think of it as a numeric or integer, let's call it. Those types for now are practically the same. Likewise for education, although we don't have any observations for Aruba in the 1960s, you can assume that there are numbers also here. Data frames are unique in that you can have multiple different data types together. We haven't talked about matrices, but if I wanted a matrix, for example, that's a different data type, all of these columns would have to be the same thing. They would either all have to be character variables, or they would all have to be integer variables. Here, we don't have to make that choice. Each column can hold a different type of data, and that's very useful because, in fact, a lot of the time, the data that we work with varies. We may have an ordinal variable, like for example, when we looked at the iris data set. Let's take a look at that. When we have our iris data set, we have one variable that is a character variable, and then we have 4 variables that are numeric variables. We need some way to hold these things together, and a data frame does a very good job of doing that. So let's take a look at this again. When we want to access different elements in our data frame, there are a couple different ways to do that. First off, we can use $sign notation. If I want to look at what the values are of a specific column, I can write the name of the data frame, the $sign, and then luckily RStudio kind of pulls up my options for me. Let's say I want to look at year. And if I run that, it's just going to print out every single value of year that I have from the very first row to the very last row, which is 15,500 rows later. It'll stop at 1,000 so that it doesn't completely overwhelm your computer, right? But if I want to access pretty much any column, I can do this with $sign notation. There is also a different way of doing it. Notice that since a set is a one-dimensional object, meaning there's only kind of a row or a column, we only needed to put one number in here. But with a data frame, there are two dimensions. So we need to tell it not only the row, but the column that we're interested in. So let's take a look at our data again real quick. Why don't we pull up row 2, column 3. So if we did that correctly, we should get, it'll look in this row and it'll look in the third column. And we should get 1961. So let's go ahead and run that. Sure enough, that's what we get, right? This type of square bracket notation is very helpful when you do things like for loops. Although most of your manipulation should not be done in a for loop, every now and then you'll need to use it, and it'll be really helpful to understand how to access items in a set or in a data frame with this square bracket notation. So, terrific. We've done a few things by now. This shouldn't be too long of a lab. Let's talk about lists. Lists are kind of a goofy object type. A list is basically an all-purpose bucket that can hold together numerous different types of objects. So you'll notice here that we have sets, we have a data frame. So why don't we create a list? Example list. And when you want to create a list, you obviously have to open it up with the function list. And why don't we say put education in there, put my mixed set in there, and then put the electricity data set in there. Let's go ahead and run that. And here it is. Here's our list, right? It's a large list because we have a lot of stuff in there. And why don't we take a look at our example list and see what's going on here. So it's basically just holding each of our different objects together. Another thing you might notice is that there are double square brackets. When we want to access items in a list, we use a double square bracket. So if I did example list, open double square brackets, 2, close double square brackets, I would get this character vector, right? In fact, why don't we go try that right now? Why don't we do example list double square brackets 1, and sure enough, we get back whatever was our education data set, right? If I do 2, I'll get the set, and if I do 3, I'll get the electricity data set. A list just holds things, and in fact, though you may not know it, we've actually been using lists all the time. A list is a very handy tool to use. Electricity, why don't we just do, on the x-axis we'll put year, on the y-axis we'll put electricity, and we'll make just a scatter plot, right? Let's go ahead and see what that looks like. Yeah, unsurprising, right? So, you know, this is kind of ugly. Actually, why don't, example of a list being used. Why don't we filter our data down from electricity real quick. Filter, and let's just look at country equals Albania, just for the sake of it. Why don't we do that? Why don't we rerun our data? Okay, for whatever reason, this is what the electricity looks like in Albania. They had a, I don't know, kind of a rough 2018, 17, 16, something like that. Don't really know what's going on in Albania, but hope they figure it out. Besides the point, right? Why don't we actually take a look at what exactly our ggplot object is? Well, surprise, it's a list, right? Because in fact, all of the stuff that ggplot needs to do on the back end for you is basically just a set of instructions that take on multiple different object types. For example, you'll notice that many of these are lists themselves. Data is a list, right? It stores your data that you pass into it as a list of vectors. a list of sets. There are different layers that you use, and look at that, the layers argument is also a list with many of these other different kind of irrelevant items for you to know. What's important for you to understand is a list is a super handy way to put multiple different data types together. And in fact, let's go back and kind of look at how let's clean this up. I don't want to be distracted by this. Let's go back and let's put together what we've learned about our lists. A list is just a way for you to put many different things together. So once we call item 3 in our list, which is the electricity data set, basically what we've just done is say, yeah, now I'm working with a data frame. And in fact, we can manipulate it as we would any other data frame. If I put the $sign after that, I can get the country variable. Likewise, if I want a specific column, I can say, give me row 100, column 1, and that's what we get, right? We get the value in that cell right there. So you can chain many of these accessing operations together. Although in general, there are more elegant ways to get that done. It's not a bad way to kind of look at it, right? So understand that all of the things that you're learning can be put together one after another. And if you find yourself needing a specific observation or a row, or you put something in a list, that's how you can access it. Okay, so we've covered a lot of stuff so far. Why don't we cover the in variable? And let's start with using in. We've used a lot of logical operators so far. Many of those logical operators kind of only made comparison to a constant. For example, in the last lab, we said, if the life expectancy is greater than average for that region, or, for the global average, then return one value, and if not, return some other value. Every single time we were doing that, we were really just comparing to one value, but often we need to say, hey, if it's any one of these things, just go ahead and keep it, and if it's not, don't. For example, let's say I wanted to look at multiple countries, not just one country, in our education data set. Now, of course, the way to do one country is to say, start with your data, do a pipe, and then open your filter function and say the country should equal, I don't know, Tanzania. And sure enough, we get Tanzania, right? But if I want more than just Tanzania, it's not enough to use a double equals, right? I use Tanzania, and why don't we just try, and what if also the country should equal Turkey? Doesn't really work, right? Because what this comma is saying is I want you to include any row where country equals Tanzania, and also, that's what a comma means, and also country equals Turkey. Well, since you can only have one value for a country, there's not going to be any row where both of those things are true. We need something a little bit more elegant. What we need is the in operator. And in fact, since we need to give this argument multiple countries, we need to go back and give it a vector or a set. And we can say Tanzania or Turkey. Right? So here's this set. And basically what in is saying is, look at the value in this variable. If it is in this set, keep it. Otherwise, don't. So let's go ahead and run that, see what we get. So Tanzania, and why don't we view that real quick? Yep, Tanzania. No Turkey. Did I misspell it? There we go. Tanzania and Albania. All right, I don't know. Maybe Turkey's official name is different than just Turkey in this data set, and I don't really have the patience to kind of go through that right now. Oh well, good thing we checked, right? You always want to check your work, and looking at it is a good way to check your work. So, terrific. We've used the in variable. Why don't we assign this, and why don't we finish off our analytics workflow, which always ends in a visualization and analysis. And why don't we just stick with the visualizations that we've kind of been making so far. So open up ggplot. We know our data is going to live in the viz object because we just assigned it there. We're going to say on the x-axis, I want you to put year. On the y-axis, I want you to put education. And then I want you to put not only a geom line, which looks pretty good, but I also want you to put a geom point there, just to kind of emphasize where the data points are. Whoops. And on the color axis, we're going to put country. Terrific, right? This is kind of goofy data, but you know, it'll live, it'll be fine. Terrific, right? So we just went from munging, using in, to creating a visualization. And you know, when you look at it, you can say, oh, okay, you know, like in 1992 and 3, there was severe decline in education rates in Albania. For some reason, it would be interesting to see what was happening in those years. And then somewhere between 2000 and 2010, you had a very steep spike in the level of education in Turkey. So we don't have data for those years, but it would be interesting to see what's going on. That's kind of my interpretation of this. And all of this was kind of made possible by in. Of course, we don't have to just have 2 countries. You can have more than more than 2 countries. You can put as many in here as you want. So let's do Mexico as well. Let's kind of run it. And, you know, damn, good job, Mexico. Going from 1970 to 2020. Insanely high education rates. Well done. That's very exciting, right? And it was trivial to add this additional country, right? Once I've written in, I can add as many items to this set as I want. So that's the in. That's the in function. Terrific. So the last thing that we're going to look at today is left joins. You'll notice that we've been working with 2 data sets, education and electricity. And while they look very similar, what we really want is for them to be in the same data set, in a data set ideally called data or something like that. We want to plot what access to electricity might look like against education rates in a given country. Now, I could just kind of tack on the additional column to either one of the data sets. I could just take the electricity column and just paste it onto the end of this whole data set, right? And in this case, that would be okay because, you know, we know the order is the same. We know there's the same number of rows. We're not really too worried about a mismatch, but I mean, a mismatch might happen, right? Some rows might have gotten flipped in there, and if we just pasted the column as is, we wouldn't get the right data for the right country. A better way to do it, in a way that you should be doing it every time you need to join 2 different data sets, is to use a join. So let's look at our education data set, or rather let's look at electricity and take a look at our data set. We have 3 variables here, and all 3 of these variables I'm going to say are called unique keys. What do I mean by that? What I mean by that is, actually there are really 2 unique keys, but whatever, we'll call it 3 for now. To uniquely identify a row, you need country, code, and year, right? You need all 3 of those variables. So for example, there are multiple observations for each country. There's a different one for every year. So if you know these 3 variables, you know exactly what row you're talking about. And in fact, there are no duplicates of Aruba in 1960. There's only 1 row for that country in that year, right? So these are the keys. And if we look at our education data set, we'll notice it has the same keys: country, code, and year. So what I need is a way to tell R, hey, I want you to put this column on this data set. And the way I want you to do that is I want you to start in row 1, and I want you to make note. What country are we looking at? What's the code? And what's the year? And then I want you to go to the other data set, and I want you to find the match for that. And in a new column called electricity, I want you to put whatever the value is in that column. So it's doing matching. We're not just blindly copy pasting a column onto our data set, because again, the rows might be of a different order. There might be other data inconsistencies that we're not sure of. Here, we're telling it, look at for these 3 specific variables. So let's go ahead and do that. Let's start with our education variable, and then a pipe, and then I'm going to do left join. And there are kind of, in this case, we really only need one argument, which is what is the new data set? Electricity. And if we left join on electricity, you'll notice that we now have 2 variables here, right? It did exactly what I said it was going to do. And in fact, notice the message that it sent you, that it gave us. Since we didn't specify which variables to join on, it looked at both data sets and it said, these are all of the columns that both of these data sets have in common. I'm going to assume that I should match on these columns. And in fact, if we wanted to do that explicitly, we would say by, we would say country, code, and year. And you'll notice that it didn't print out that message this time because we told it exactly which variables to match on. So it wasn't saying, hey, I assumed that these were the variables you wanted to match on. I already told it what variables to match on, and so it did that. So that's a left join. Joins are very powerful tools. And once you kind of master joins along with data munging, you'll be 95% of the way there to having really good visualization stuff. So now that we've joined our data, why don't we go ahead and visualize it? Again, open a ggplot command. We're going to tell it our data is in the viz object that we just instantiated, that we just assigned. We're going to open up our aesthetics, and let's say on the x-axis we want education, on the y-axis we want electricity, and then we just want a scatter plot, so we're just going to do geom point. So let's go ahead and run that, see what we get. A lot. There is a lot of data here. It looks very linear, but kind of unsurprisingly, it looks as if once you get to the higher rates of education, electricity is pretty much at 100%. It's really difficult to think of a country that has super high rates of education and not constant access to energy, right? Likewise, most indicators of development are very highly correlated. You can basically see with your eyes the linear trend that goes from 0 to about 75%, 80% access to electricity. Once you kind of pass this seemingly high threshold of education, electricity more or less tops out, right? We couldn't have made this visualization with our old format, with our data in 2 different data sets, but we can now that it's in 1 data set, so that's very helpful. Okie doke. So today we've covered a whole bunch of, I don't want to call them odds and ends, but important and interesting things for you to kind of know as you get further on in your analytics career. We looked at a number of different types of data objects. We looked at sets or vectors. We looked at data frames, which you're fairly familiar with by now, and we also looked at lists, which, although unknowingly you have been using them in the form of ggplot this whole time, though you haven't been explicitly constructing a set. ggplot works entirely off of lists. So we looked at those 3 different data types. We looked at how to access data in those data types with a single square bracket for sets, with the $, and the 2 element square brackets for data frames, and the double square brackets for lists. We also looked at the in command, the in logical operator. How do you kind of say if this value is any one of these values, then add it, keep it, and if not, don't. And then lastly, we looked at a left join, which kind of puts our data together. So this lab will be relatively short. We really don't have too much more material. We don't have any more material to go through. So at this point, you should really be thinking quite hard about what your final data set for your final project is going to be. You have the ability now to manipulate data. You have the ability to put disparate data sets together, and you should be getting quite familiar with visualization. We threw this together in a matter of seconds, and I suspect that you should kind of be getting a little bit more comfortable with this syntax. You should be able to read this visualization and say, yeah, I get it. I kind of know what to expect here at this point. And you can implement something similar for yourself, right? So think about what data you want to use for your final project. Come talk to me if you have an idea and you're not quite sure about it. And as always, don't forget to practice a little bit every single day. That'll make your life very easy in this class and in the rest of your life. So, all right, I hope you have a wonderful day.